So here we have a function f of x. I can see that it's a cubic function. Since the leading coefficient is positive, I know the end behavior would be as x approaches infinity, y approaches infinity, then the opposite in the other direction. So this cubic is going to loosely look something like this. Now, some cubics have a relative minimum and a relative maximum, as this one appears to have, and some do not. Some instead, like the parent cubic, look kind of like this. So there's still this like change happening here, but it's not creating a maximum and then a minimum. So we're going to be thinking about looking at where the critical points would be for this particular cubic function. So as a reminder, a critical point is where there's a horizontal tangent or where the function's slope is undefined. So horizontal tangents would occur at a maximum and a minimum, and they occur where there's a slope of 0. A horizontal line has a slope of 0. In this other little cubic drawing I created, even though it looks kind of strange, this is also a horizontal tangent because at just this one point, it is reaching a slope of 0. Okay, so in order to figure out where this particular cubic function has a horizontal tangent or has critical points, I'm going to think about its derivative. So remember that the derivative represents the slope or the instantaneous rate of change of a function. So I'm going to find the derivative function for f of x. So I'm going to find what f prime of x would be. So I'm just applying the power rule to each term. So this would give me 3x squared plus 14x plus 8. So this function, f prime, it is still a function, but it's the derivative. It is representing the slope or the instantaneous rate of change of my cubic. Again, I'm looking for where the cubic would have horizontal tangents, meaning where its slope is equal to 0. So I'm going to take my derivative equation and set it equal to 0. Now, as we know from algebra, when I have a quadratic, if I'm trying to solve, I probably am going to need to factor, or that is one of the methods I can use to find the solutions. So that's what we're going to do here. So 0 equals, all right, I'm going to try and factor this into two binomials. Now, my a value, that leading coefficient, is not 1, which makes this a little bit more annoying to kind of think through, but 3 is a prime number, which makes it a little bit simpler. So because 3 is a prime number, its only factors are 3 and 1. So that means one of my binomials has to start with 3x and the other has to start with 1x, or just x. Now for my c value, the plus 8 is not a prime number, so there are a couple of options of what values could be in the second position for each of these binomials. But let's just try and kind of think through it. So this 3x is going to be multiplied by whatever number is here, and then I'll be adding it to whatever this number is times x. Whatever this number is times x. Okay, so if I think about the factors of 8, I could use 8 and 1. If I put 8 here and 1 here, for example, okay, 3 times 8 is going to give me 24. Okay, that's going to be way too big. It's not going to give me 14. All right, if I switch and I put 8 here and 1, all right, 3 times 1 is 3. 3 plus 8 is 11, so that's also not going to give me 14. So that means my factors I need to use must be 2 and 4. Okay, so let's try a 2 here and a 4 here. All right, 3x times 4 would give me 12x plus 2x is 14x. Okay, so these work. So 3x plus 2, x plus 4. So these are my two factors. So if either of these factors is equal to 0, it's going to make this entire equation equal 0, meaning it's going to tell me at which x values, or I can use these factors to determine at which x values I have a slope of 0 in f. So let's set each factor equal to 0. So 3x plus 2 equals 0. If I subtract 2 and then divide by 3, that's going to give me negative 2/3. And then if I set x plus 4 equal to 0, that means when x is negative 4, I have another critical point. That's another place where the derivative is equal to 0. So this tells me that, thinking about my graph again, let me draw a slightly better graph over here. So that tells me that if I imagine my cubic looking something like this, very loosely, then I would have right here at x equals negative 4, I would have a horizontal tangent or a critical point because the slope would be equal to 0 there. And then over here, another horizontal tangent where the slope is equal to 0, and that would be at x equals negative 2/3. So that is